Algorithms, context. Right? Think about XGBoost, spend time feature engineering. If you're working with BERT, you have to think about the max sequence length. We've always had this tension between the latest algorithms and working with the context. So what I want to do is we're going to go through a journey here today around this. Now, for background, I'm the chief evangelist at Contextual. I like to play around with AI. I like to talk about it, so they gave me the chief evangelist title. I also like to make videos as well in my spare time. So some of you have seen me on like Instagram or TikTok as well. But what I want to do today is we're going to walk through the role of context. And we'll start simple with traditional RAG, where we have static context. We'll spend some time on how we engineer context to be able to get better performing RAG systems. Then we'll move into some of the newer innovations with the latest models where we can now have dynamic context because the models can make these decisions. And then finally, we'll end with some cool stuff around multi-agent systems where now we need these agents to collaborate and work together. Now, I think as a starting point, we all know that LLMs have the knowledge of everything. Right? They've been trained on everything. They know everything. I think we can all agree on that. Hopefully you guys don't agree on that, right? We know they don't have everything, right? Like we have to inject information into the LLMs, into context windows as a starting point. For those of us who work in enterprises, who have existing information, documents, this is where RAG comes about, where we take all the knowledge we have, we chunk it into little pieces, so that way we can cram it into large language models and use them. And my guess is many of you have played with the LangChaMA indexes and built your own simple demo RAG systems, and it's very easy and trivial to do that. But as you try to scale that up, you want to move that into production, all of a sudden then it's like how do you get the accurate chunks, the accurate context you need? Or you end up with so many chunks, so much context that your latency goes up, that all of a sudden the cost of this has skyrocketed. Not only that, you got to think about the infrastructure. It's one thing when you work with 100 documents in a demo. It's another thing when you scale this up to tens of thousands of documents, millions of pages. And then in an enterprise, there's the context that you also have to worry about, that not everybody has access to every document. You have to think about building entitlements in as well. So this is like the reality of it. But when we talk about context and context engineering, even in the case of RAG, there's a ton of different tools and mechanisms that come into place. So think about a simple query where you're going between that query and answer. Well, you have to think about, when is that query getting reformulated? What are the prompts that are being used? How are you handling memory, chunking? All of these are the tools that we're going to use inside of context engineering to build stuff. Now, at Contextual AI, we've been working on this for a while. Our founder wrote the original RAG paper. And I want you to all think about all of these pieces, not as a single model, but you really have to build a system, whether it's bringing in that information and ingesting it, whether it's querying it, whether it's retrieving it, generating the answer. It takes a lot of engineering effort to build this. So this is the first part I want to focus on, is how we can engineer this context to get more out of it. And there's a lot here. This is where after the thing, you can come to my booth. I can go through all of this stuff. But for today, I'm just going to focus a little bit on this retrieval, because there's a lot of confusion. I see a lot of different directions on this piece. And we talked about that pendulum going back and forth. I want to talk about 3 different types of algorithms: BM25, language models, and then the newer language models where we can now do agentic search for them. So we'll start with the basics. BM25, which stands for best match. It's a lexical technique. I like to think of it as you get all of your documents, you build this inverted index. So we take all the words that are in your documents, figure out what documents they point to. So if I have a new word that comes in, butterfly, I can kind of figure out which document is most likely like that using a probabilistic approach like that. The other thing this algorithm should give you hope for is for those of you who write temp 1, temp 2, temp 3 in your notebooks. They got to 25, and then they got something good. Now, the performance of VM25 is really good. It's really fast. It's very efficient at scale. We see it widely used. Most of you are probably familiar with it. However, we know this type of algorithm has a failure. If I'm asking for physician, but the document has the word doctor in it, there's not a lexical overlap. Right? The algorithm's going to fail here. International business machines and IBM. So that's one of the limitations of this. But despite that, this is a strong baseline. I think most of us will use lexical search. So it has these limitations. But we've got better algorithms. So this is where language models came into place, where now we have models that have been trained on vast sorts of information, language that understand the subtleties of language, and we can use that. And with the language models, what we find is that now that same problem I had with doctor and physician, all of a sudden, for the language model, these things are similar to each other. They're in the similar latent space. Or international business machines and IBM. So this is the power, right? That we have a better algorithm now that can better squeeze information out of this, and we apply this right away to RAG. We take the query that comes in, we create an embedding of it. We take the content that we had, we create embeddings of that, because now we can use this power to do this. Now, of course, there's a ton of embedding models out there, and this is where you can go out and pick based on what you're looking for in terms of retrieval performance, what you're looking for in terms of latency and CPU costs to do that. But what I want to do is show you one thing kind of to move on a little bit beyond that. So the embedding model focuses on one aspect of that context. So typically you bring your documents, you bring that in the embedding model. But what if we want to look at both the embedding models and the query? Say we want to cross those, cross encoder. This is what a re-ranker does. It does it's a more complicated relationship between the two. It takes a little bit of time, but it gives us a better understanding of the relationships of those. And so in a common engineered RAG system, what you'll find is we'll add a second stage where that initial stage, the embedding models, but then we'll re-rank it with this improved model like that. So this is one way we kind of can engineer out the improvement. And I tried this myself, like Contextual has a re-ranker model. I can try the performance with the re-ranker, without the re-ranker, and I can see I can get a boost in retrieval performance like that. Now, beyond that, the re-ranker algorithm, we can also use it as a language model, even make it promptable. So we've added the ability to do instruction following with our re-ranker. So I can ask for, what is the most recent information? Give me the professional information. So this allows us, again, like these are the knobs we have to better engineer the context and improve the performance for what we're doing. And of course, right, like you can always grab all these techniques, shove them together as another way to engineer it to improve it. And we see this all the way at the top at where like the Kaggle competitions, where there literally will cascade multiple re-rankers in order to kind of squeeze out the performance. So this is where you can kind of make your decisions for how you want to do this. Now, that's a little bit over the top for me. I think this is a better kind of baseline for everybody that's out there building these things, is you use that combination of semantic and lexical search is a good starting point like that, using a re-ranker. And so when people ask me about their RAG systems, this is, I think, widely held as like a good baseline to start with. But like sometimes your queries aren't very clear. Sometimes maybe you are shoving too much into a query, and these systems don't work as well for that. But we've got more, right? This is where the dynamic context comes along, where now what we can do is move to an agentic approach, where instead of single shot, I can do multiple types of queries to be able to get at this. Now, this comes about because we've had the latest generation of large language models now has the ability to use reasoning, to use tools. They can use this reasoning to dynamically retrieve the content we want. They can change the queries, identify information that should be pulled in through that. Now, just to put this side by side, the old-fashioned RAG was you'd ask a question, it goes kind of straight through the piece. Now we have an agentic flow that can loop back in, double check, hey, was this answer complete? Am I missing something here? Maybe I should look for physician notes instead of doctor's notes. It can make that change and look for information in that way. Now, I always run these things on our platform myself to kind of be able to run this. Oh, this is, sorry, too far ahead of myself here. So this is what that looks like when you run the results through. If you're using an agentic approach where you're going to have a model that's thinking about what it's going to do, it's going to grab different search tools along the way. You can then see what those tools are doing, what types of searches, what are they pulling out, what are the results that are coming out. But then what you care about is the final output, right? A much better cohesive output by using this. Now, I always have to kind of try these things out for myself. So one of the things I found was this great Wix QA data set, which is a public data set that's available, that's on technical support questions from Wix. They released it and made it available out there. And if I try just traditional kind of single shot RAG, I get like 76% on their kind of factuity benchmark. So like, okay, not great. But as I hooked it up to the agentic RAG, where I hooked it up to the LMs where it can do repeated queries like that, like the performance just shot up out of the roof. And I have not spent any time trying to like improve this. This is just like straight out of the box kind of things. Now, do you get everything for free in life? No, I mean, there is a latency penalty here. So this is where you have to, as a developer, decide on your trade-offs like that. So then I got intrigued by this. I looked and I found this bright data set. And so this is a data set that's built around retrieval reasoning. It doesn't have the simple kind of questions that if you synthetically generated your own data set, like it's got really deep reasoning questions to have that. So I reran all my tests kind of, or no, I didn't reran these. This is from the paper. They share some results here. So if you look over on the right side here, this is Quen. So this is an embedding model they used. They used the Quen embedding model. And you can see they do the best there with the Quen embedding model with GPT-4. And right, it makes sense. Like that's a pretty good model. But take one look. Look at this other thing on the graph here. Look over here. What is this? What is this? That whole boring BM25 thing I brought up in the beginning that you guys roll in your eyes. Look at that. You get better performance using that lexical approach with GPT-4 than using an embedding model. Like this was kind of mind-blowing to me like that. So I went out and kind of tried this out myself, just again, really quickly on our platform. Tried it out on 2 different data sets. I used that Wix data set, but we have another financial internal data set of 10Ks like that. And you can see, like, look, like I can get pretty much the same performance just using BM25 and one of those state-of-the-art LLMs. Like, I mean, wait till Big Vector sees this, right? Like, you don't need to have an embedding model to get really good results like this. Now, we see people doing this. You see this already for code, which was never a great place for embedding models. But I think there's some earlier talks that talked about this too. Right? If you use things like Claude Code, they'll use grep search for being able to do everything where you're taking advantage of these models to do that. So this is great. But here's the thing. As you do this, right, like we have one model working, like you're loading the model with all of these search tool calls and you're filling this context as you're doing the search, what's going to happen, right? The model's going to get bigger and bigger and bigger, and it's going to not be able to kind of handle that load. And so this is where we move to the final chapter here, where we talk about multi-agents and kind of collaborating and spreading out the load, because it's been shown when we go to multiple agent systems, they can perform better when we're hitting all of these limits from these single agent systems. Now, multi-agent systems, I think they started getting really big this last year. I think Anthropic, they've read a blog post about everything, kind of has a nice blog post on it. And if you look at the example here, kind of, right, if people are like, what, is this multi-agent just a bunch of extra tech stuff that we're selling? No, like think about a query like this, like identify all the board members of the companies in the information technology S&P 500. right? Like if you think about that, like if you have one intern working on that versus 10 interns, right? The 10 interns are going to be able to do it much faster. It's easily a task that you can parallelize out in that way. And that's kind of the way we can think about using agents to be able to do this sort of work. And we're seeing early results from people using these multi-agent systems. So this was a recent paper where they broke down the work, where they had different agents for the generator, for the trajectory, for insights, and they were able to, in this case, generate better prompts, better utilize memory through this approach. Not only there, so Capital One kind of recently shared, they did a talk at the NVIDIA conference where they talked about their conversational AI system, where they had an understanding agent, a planner agent, and an evaluator agent all working together to be able to solve things. Now, at Contextual, we've also kind of tackled this problem as well, where we focused on log analysis. We have a lot of customers that have kind of like Qualcomm that has lots and lots of data, lots and lots of log data. Their folks spend a lot of time going through that data, doing root cause analysis, and we figured out like if we break up this task into different parts, we can actually solve it much better, where we have different units that work on parsing out the files versus something else that does root cause analysis that looks for multiple hypotheses along the way. And so this is kind of an active area. I don't have like huge insights to kind of share upon you, but I think this is where us and others are doing this cutting edge, where we have multiple agents working and collaborating together with each other. And I mean, some of the things that we've realized already in doing this is like with multiple agents, for example, we can ingest a lot more documents a lot quicker. We can parallelize out a lot of that workload around that. We can also, when we're doing that root cause analysis, thinking through like how best to solve the problem, well, this is another great area where we can have different sub-agents that each take their own hypotheses and kind of look for the answer. And of course, right, this is modern AI, we can trace all this stuff and follow this. So it's a very effective co-pilot for people to help improve and do their analysis as well. So lots of cool, exciting stuff going on here. Okay. I wanted to put as much as I could into this. So hopefully here, I've kind of at least re-energized you thinking as much as we hear about all the latest algorithms, all the pieces that are going on, but we also remember we have to think about the context, right? That's all the pieces there that we can feed that can make the most effective use out of this. And whether it's your traditional static RAG, whether it's taking time to engineer your RAG, using the latest models. Like I think agentic search, we're already seeing it really take up. I'm guessing, 6 months from now, most of our customers will be using agentic search for most of their use cases like that. It's just so powerful in that way. And then, right, I think multi-agent systems, we're all going to see like where the best value is out of these, like where the best use cases are for this. But it's an exciting time that we can kind of use these different techniques like this. So thank you all. I know it was a crowded room. Thank you all for kind of sitting and listening to me. I love Weights and Biases. I'll be around all day today to answer questions. We have a booth and I'll be headed back there if you want to ask more questions, as well as if you want to see demos of the platform or any of that. So thank you all.
Thanks a lot.